Hi guys, in the last video we have discussed the nomenclature of fused ring hydrocarbons. In this video we will be discussing about the nomenclature of bridged bicyclic hydrocarbons and spiro hydrocarbons. Nomenclature of bridged bicyclic hydrocarbons and spiro hydrocarbons. So what are bridged hydrocarbons and what are spiro hydrocarbons? See here, in bridged hydrocarbons also, as we have seen in case of fused hydrocarbons, two rings will be fused together. So here bridged bicyclic hydrocarbons. So two cycles or two rings will be fused together, as we have seen in case of fused ring hydrocarbons. And here in bridged bicyclic hydrocarbons, the rings will be sharing two or more atoms. If we observe the fused ring hydrocarbons, in these fused ring hydrocarbons only two atoms, two common atoms we have seen. It is orthofused and this is ortho and perifused. So these are fused ring hydrocarbons. So in fused ring hydrocarbons only two atoms will be common for two rings. But here in bicyclic hydrocarbons, two rings will be sharing more than two atoms. Two atoms or more than two atoms. Such atoms we will be calling as bridged bicyclic hydrocarbons. So here, how to name these bridged bicyclic hydrocarbons? So let us take an example. So let us consider this compound. This will be one cycle and this will be another cycle. I will make it different colors. Yeah. So this is one cycle and this is another cycle, and both the cycles they are having 1, 2, 3, 4 common atoms. So while naming these bicyclic hydrocarbons, the first rule we have to remember is we have to identify the major functioning identity, or we can say the functional group. So here if we observe this, we can easily say that this is a saturated compound. So this saturated compound, the identity of this compound will be ANE, AN. So the saturated hydrocarbons are given the suffix as AN. So this will represent the functional group or the identity of the compound. After that, we have to count the total number of carbon atoms that are present in both the cycles, or we can say that are present in the entire compound. So here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So total 10 atoms are present. So if 10 carbon atoms are present, then the prefix DEC, DEC will be used. combination of this prefix and suffix, this will be the root name of this compound, decane. So this is the root name or parent name of the compound. So the first rule is we have to find out the highest priority functional group. The highest priority functional group we have to find out in the compound. So here the highest priority functional group will be the saturation. Okay, or the highest priority characteristic of this compound will be the saturation. So here, as this compound is completely saturated compound, we are using ane as the suffix, and the second rule is we have to count the total number of carbon atoms that are present in this entire compound, and the respective prefix we have to use. So as here 10 carbon atoms are present in this compound, we are using prefix dec. So the combination of this prefix and suffix will be the root name of the compound. Then after that, we have to identify the two rings. So the first rule, we have to identify the highest priority functional group. Second rule, count total number of atoms. Then third rule, identify the two rings. So here one ring will be 1, 2, 3, 4, 5, 6. So this is one path, and another ring will be 6, 7, 8, 1. So this will be the another path. So here in bicyclic ring system, we have two rings. One will be 1, 2, 3, 4, 5, 6, 10, 9. Okay, and another will be 1, 9, 10, 6, 7, 8. So these are the two rings. Okay, and here we will be having two paths. One path is 1, 2, 3, 4, 5, 6, and another path is 6, 7, 8, 1. Okay, so C1, C2, C3, C4, C5, C6. This will be 1, and C6, C7, C8, and C1. See, I am not writing this common atoms here right now, the bridge atoms I am not writing here right now. So here this will be one cycle and this will be another cycle. So these are the two rings that are present here. So now here the carbon atoms at which both the rings are meeting, these carbon atoms will be called as bridge head carbon atoms. So bridge head carbon atoms or bridge head atoms. So the atoms at which both the rings are meeting together will be called as bridge head atoms, and the atoms which are in common for both the rings will be called as bridge atoms. Okay, now, so here, now what we have to do, we will be numbering the carbon atoms. So we counted the total number of carbon atoms. We first of all we selected the highest priority functional group. Then we counted the total number of carbon atoms, and we have taken the root name decane. Then we identified the two rings and also the bridge head carbon atoms we have identified. They are carbon 1 and carbon 6, and bridge atoms also we have identified carbon 9 and carbon 10. So these are the identifications what we made here. Now after this, what we have to do? We have to count the number of atoms that are present in each path. So here, one path we will select 1, 2, 3, 4. See, before that, what we have to do? We have to give numbering to the carbon atoms. So this numbering will start at one bridgehead carbon atom and it will continue to the second bridgehead carbon atom in a longest possible path. See here, in this compound, we can give numbering in two ways. So this will be one way, and another way also we can give numbering like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. See, if we give numbering in this path, this will be the first bridgehead carbon atom and the second bridgehead carbon atom will get the number 6. If we give numbering in this way, then this will be the first bridgehead carbon atom and the second bridgehead carbon atom will get the number 4. But according to the rules, we have to proceed towards the second bridgehead carbon atom in such a way that the second bridgehead carbon atom should get the highest number, or we can say the numbering should proceed from first bridgehead carbon atom to second bridgehead carbon atom in the longest path. So in this case, this will be the longest path and hence we will be considering this numbering only. Okay, so like this we will be giving the numbering. So the next rule is numbering. This numbering should be in such a way that it should continue to the second bridgehead carbon atom in the longest path. Then, after numbering, we have to count the total number of carbon atoms or atoms that are present in each path. Okay, so here this will be one path, this will be one path, and this will be one path. Total 3 paths are there. One path belongs to the highest, longest ring, or we can say the major ring, or and another path will be the smallest ring, and another path will be its of bridge. So here we have to count the total number of atoms that are present in each path. So in this, while counting, we should keep in mind that the bridgehead carbon atoms will be excluded. Okay, while counting, we have to keep in mind that the bridgehead carbon atoms are excluded. Okay, so now in this counting, so 1, 2, 3, 4. In one path, 4 atoms are present, and 1, 2. In another path, 2 atoms are present, and in another path, 2 atoms are present. Okay, so here 3 paths are possible, and in these 3 paths, these many atoms are present. So here the bridgehead carbon atoms will be excluded. Okay. Now, after counting these number of carbon atoms, these has to be arranged in descending way. Okay, so here if we arrange these in descending order, the same order will come. Okay, now count number of carbon atoms in each path and arrange in descending order. Okay, this will be Now what we have to do, we have to prefix the name or the word bicyclo to the parent name or to the root name, and in between this root name and this prefix these numericals has to be arranged in parentheses or brackets. So the name of this compound will be bicyclo 4 comma 2 comma 2 decane. So this will be the name of the compound bicyclo 4 comma 2 comma 2 decane. Like this we will be numbering the we will be naming the compound. So first what we have to do, we have to identify the highest priority functional group. So in this compound, if we observe this compound, we can easily identify that this is the saturated compound. So we will be selecting the suffix "ane". And secondly, we have to count the total number of carbon atoms. So if we count the total number of carbon atoms present in the compound, we got 10 carbon atoms. So here the respective prefix to be used is dec. So the combination of the prefix and suffix dec plus "ane", decane, that will be the root name of this compound. Then the third rule will be we have to identify the two rings present in the bicyclic ring. So here this will be one ring and this will be another ring. Then in these two rings we identified the bridge head carbon atoms and the bridge carbon atoms also we have identified. Then the fourth rule will be we have to numbering the compound. We have to give numbering to the compound. So while giving numbering to the compound, the numbering should be in such a way that it should start from one bridgehead carbon atom and it should continue to the or proceed to the second bridgehead carbon atom in the longest path, and we did that. Then finally we have to count the number of carbon atoms in each path, and that number has to be arranged in descending order, and we did this. Then what we have to do, we have to use a prefix bicyclo for all the bicyclic compounds, and in between this bicyclo, the prefix bicyclo and the root name, this descendingly ordered numericals has to be arranged. So the name of the compound will be bicyclo 422 decane. Like this we will be naming the bridged bicyclic compounds. So what if these are unsaturated compounds? So here unsaturation is present. In such a case, what we have to do? If unsaturation is present, then we will be taking the suffix "ene". So the respective hydrocarbon, straight chain or open chain hydrocarbon name we will be selecting here as the root name. So here 10 carbon atoms are present, so the prefix dec will be selected, and as it is having unsaturation, the suffix "ene" will be selected. So this will become decene, and the position of this unsaturation will be designated with the numericals. Okay, as usual. So bicyclo 4 comma 2 comma 2 dec 3 ene. So like that we will be naming the compound. Of it one more unsaturation is present, then what will be the name of the compound? Then here two unsaturations are present and these two are double bonds only, so diene, suffix diene will be used. So decadiene. So the name of the compound will be decadiene. So here at the third position and fifth position unsaturations are present. So how we will be naming the compound? Dec 3 comma 5 diene. So the name of this entire compound will be bicyclo 4 comma 2 comma 2 dec 3 comma 5 diene. So we'll write the name of this compound like bicyclo 422 dec 3 5 diene. So like this we will be naming the compounds if it is unsaturated. Okay, if triple bond is present, then instead of ane or instead of yne will be used. So like that we will be naming these unsaturated bicyclic compounds, bridged bicyclic compounds. Now, how we have to name these spiro compounds, spiro fused compounds? See here, in spiro-fused compounds also, the atoms will be fused in such a way, the compounds or the rings will be fused in such a way that they will be having only one common atom. Like this. Only one common atom will be there for the compounds. So in spiro compounds are such compounds in which the rings are fused in such a way that they will be having only one common atom. See, while naming these spiro compounds also, we will be following the same rules what we followed in case of bridged bicyclic compounds only. But here only one exception we will be having. That is, in while naming these spiro compounds, we will be excluding this common atom. We are not counting this common atom. See, while naming the bicyclic compounds, bridged bicyclic compounds, like this, while naming these bridged bicyclic compounds, what we are doing, we are counting this two atoms also, the common atoms also, or else we can take the same example what we have discussed. So we are counting these bridgehead carbon atoms also. So while we are giving numbering also, total 10 carbon atoms we are considering, and we are considering this molecule as decane. Here also, this will be called as nonane. Okay, so this compound we named as bicyclo 422 decane. This will be named as bicyclo, and this is 1 2 3 4 and 1 2 3, and this is 2, so 4 3 2 nonane. So like this, we named these bicyclic compounds, bridged bicyclic compounds. So while naming these spiro-fused compounds, what we are doing, we have to exclude this common atom. So the first rule, we have to select the highest priority functional group, as it is the saturated compound. The functional group or the character or the identity of this compound will be, it is an alkane. So the suffix "ane" will be used. So secondly, what we have to do, we have to count the total number of carbon atoms present in the compound. So while counting, we will be excluding this common atom. So here 1 2 3 4 5 6 7 8 9 10. Instead of 11 atoms, we will be counting only 10 atoms. So this will be named as decane. Okay, and the remaining will be the same. We have to number. Okay, after numbering, what we have to do? We have to count the total number of carbon atoms that are present in each path. So here 1 2 3 4 5 5, and here also 1 2 3 4 5 5. Then we have to arrange the number in descending order. After that, we have to use the prefix spiro. So here the name of this compound will be spiro 5, 5 decane. Like this, we will be naming the spiro-fused compounds. If we consider another example, So in this case, 9 atoms are present. So this will be Spiro. The name of the compound will be Spiro 4,5 nanine. So here two differences we can observe while naming these bridged bicyclic compounds and spiro bicyclic compounds. So what are those two means? Here in bridged bicyclic compounds we are including the bridge head atoms also while counting the total number of atoms that are present in the compound. Whereas in spiro compounds we are excluding the common atom. And here in bridged bicyclic compounds, we are arranging the total number of atoms present in each path in descending order, whereas in spirocyclic compounds or spiro-fused compounds, we will count the total number of atoms present in each path and those numbers will be arranged in an ascending order. These two are the differences we observe while naming these bridge bicyclic compounds and spiro-fused compounds. Okay, remaining rules will be the same. So the first rule, what we have to do, we have to select the highest priority functional group. Secondly, we have to count the total number of atoms present in the compound. Then we have to identify the bridge head atoms and bridge atoms in case of this bridged bicyclic compounds, and the spiro atom or spiro or common atom in spiro fused compounds. Then we have to count the total number of atoms that are present in each path. Okay, in both the compounds we have to identify or count the total number of atoms that are present in each path, and that count we have to arrange in descending order in case of bridged bicyclic compounds, and we have to arrange in ascending order in case of spiro-fused compounds. Okay, then in the bridged bicyclic compounds we will be using the prefix bicyclo, whereas in spiro-fused compounds we will be using prefix spiro. And in between the prefix and the root name, we will be arranging these numericals in both the compounds. Okay, this is how we will be naming the bridged bicyclic compounds and spiro-fused compounds. Okay, in the next class we will be dealing with the nomenclature of cyclic compounds that are having more number of rings. Thank you.